All right, chapter 10, section 1, lines and segments that intersect circles. Starting chapter on circles. Right now we just have main vocabulary. Okay, you have to know this vocabulary for circles because you'll hear me either mention it or you'll see it, and you have to know what they are. Also, you may have to be able to identify it. So looking at this first section, it says circles is a set of points on a plane that are equidistant from the given point in that plane. So we all know what a circle is. It's just telling you it's a set of points equidistant from the center. Okay, they're all the same distance from the center. And then looking at center, it's the given point. The center is the given point that's in the middle of the circle, if you want to say. But we should kind of know what the center of the circle is. Looking at the next one, radius. Okay, radius is a segment whose endpoints are the center and any point on the circle. So you have to know what a radius is. Please do not get this mixed up with diameter. It's from the center to any point on the circle. If you have more than one radius, it's called a radii. Okay, that's the plural version. I'm going to go ahead and draw what that looks like so you can see what a radius is. Here's my circle. Here's my center of my circle. It just goes from the center to the end of the circle. Please be aware, it does not go across through the center. It just goes from the center to any point on the circle. Chord, secant, diameter, and tangent. Again, vocabulary words that we have to know. Looking at this one, a chord is a segment whose endpoints are on the circle. Keep in mind, endpoints are on the circle. So if I'm drawing this one, here is my circle. Well, I'm just going to write it as this is considered edge to edge. Okay, one edge to the other edge doesn't matter where, as long as it goes straight through, not through, straight to the edges. Okay, it doesn't go over. Looking at the next one, I have my diameter. Keep in mind a diameter is also a chord. Okay, and it contains the center of the circle, so radius goes halfway. I'm going to go ahead and draw my diameter. Here's my circle. Here's my center. My diameter goes all the way across. Keep in mind your diameter is also considered a chord. How is it considered a chord? Because there are two endpoints. It goes from edge to edge of my circle. Looking at the next one, I have a secant. So looking at my secant, your secant is a line that is key. Remember the difference between a segment and a line. Your segment continues on and on and on. I'm sorry, your line continues on and on and on. Your segments have two endpoints. So your secant is a line that intersects a circle in 2 points. Okay, it intersects your circle at 2 points, and then you have a tangent, which is also a line. And in the plane of a circle that intersects the circle in exactly 1 point, and that point is called your point of tangency. So I'm going to draw your tangent. Here's your circle. Here's my center of my circle. We're going to call this line my tangent. Okay, it intersects my circle at exactly 1 point right here. And this point is called your point of tangency. So please make sure you understand that. Your tangent is the line and your point is the point of tangency. All right, this is a diagram with all the information. Your chord, again, just a reminder, your chord has 2 endpoints. Your diameter is also considered a chord, but the diameter goes straight through the center. Okay, halfway, they didn't write this on here, but I'm going to write, this is my radius. Your secant is a line. Okay, that's why it has the arrows. It's continuing. Your tangent is also that line or a different line. Your tangent only intersects at 1 point. And that point is called your point of tangency. So secant passes through your circle through 2 points. Okay, your line passes through at 2 points, while your tangent passes through at exactly 1 point, and that point is called your point of tangency. All right, looking at the next slide, point O is the center of the circle. Name each figure. So I'm going to try and color code these as best as I can. So looking at this, the first thing we're going to go ahead and look at is this is line OM, not line OM, this is segment OM, meaning it does not continue. So if I'm looking at OM is right here on my circle. What is that considered? That is considered my radius. Okay, that's my radius. It goes from the center to the end point. Looking at the next one, I have segment MN. Segment MN, which is right here. What is segment MN? Good, that's my chord. It goes from one endpoint to another. Looking at the next one, this is a line. Okay, this is a line. So we can see it. It has the little arrows. I have line MN, so that means it continues. What is this called? This is my secant. Looking at the next one, I have segment MQ. So here's MQ. Keep in mind it's a segment, so it has the endpoints. What is that? Okay, remember, point O is the center of my circle. So MQ is this is my diameter. Okay, this is also a chord. But because it goes through the center, we normally call this my diameter. Looking at the next one, let me grab a different color. Looking at the next one, I have ML, which is just right here. In my pink, what would ML be? This would be considered my tangent segment. So it's intersecting the circle at one point, which is point M, but it's stopping at two endpoints. So yes, we went over tangent is a line, but this we're going to call tangent segment. And then looking at the next one, I'm going to have, this is line ML, meaning it continues, and line NL would be called what? It's a line. It has my arrows. So this is going to be my tangent. And then looking at the next one, point M, which is right here. This little point, just specifically the point, what is that point called? What is it? Point of tangency. Okay. So again, vocabulary, you guys have to be able to identify these words. All right, I have common internal versus common external tangent lines. So it says draw a segment connecting the center of the circles. If the segment intersects the common tangent, then the tangent is internal. If it does not, the tangent is external. So a few things before we start drawing those lines. These lines that I'm highlighting right here, these are called my common tangents. Why are they called my common tangents? Because this is my tangent line and it's the line shared between both circles. That's my common tangent. Now, in order for me to determine if it's internal or external, what they want you to do is, with practice, you won't have to do this, but if you start at the center of both circles and draw a line from the center to the center, if it intersects, so I'm going to highlight it. If the segment intersects the common tangent, then it is your internal, okay? It's called a common internal tangent. Then if it does not intersect, it's called your common external tangent. So looking at the first one, again, a couple things you need to remember. This line is called your common tangent. I'll write it in red because it's the same. This line is called my common tangent, so just so we know. Now, is this one a common internal tangent or a common external tangent? Does it intersect? No, so is it internal or external? Good. This is my common external. This is my common external tangent. So again, it does not intersect. So looking at the next one, would this line be called my common internal or external? Good, this is my common internal. And how do I know? It intersects. Okay, it intersects. So internal intersects, external does not intersect. Okay, so make sure you guys know the difference. And again, make sure you know where my common tangents can be. There are multiple. It could also go either way diagonal, and it could go from the bottom. So make sure you understand where you can have your common tangents. All right, congruent and concentric circles. Congruent circles, circles that have congruent radii. So if I draw circles, they have the same radius. Okay, I could have multiple congruent circles. And then concentric circles, circles that lie on the same plane and have the same center. Does not mean they have the same radius. So looking at this diagram, this is an example of a concentric circle. Think of it as a bullseye. Okay, this is an example of concentric. And then if I draw circles like this, if they're perfect sized circles, okay, these circles have the same radius, but they are not on the same plane, okay? So not on the same plane. So these could be considered congruent circles. They have the same radius, but not on the same plane. One is on this plane over here, and one is on this plane. So these are on two different planes, while my bullseye-looking circle is on the same plane. All right, looking at the next slide. Tangent circles, coplanar circles that are tangent to the same line at the same point. So key thing here is they're using the same line, and they are touching at the same point. So looking at these circles, these are tangent circles. Coplanar again means on the same plane. They're circles that are tangent to the same line and same point. They touch my tangent line at the same point. All right, looking at theorem 10.1, please make sure you understand the concept of this. It says, in a plane, a line is tangent to a circle if and only if the line is perpendicular to a radius of the circle at the point of tangency. So what does that mean? Here's my tangent line. This is my point of tangency. This is my radius. If my radius is perpendicular, okay, to my tangent line at the point of tangency, that means I have a 90-degree angle. Okay, my line is tangent to a circle if and only if the line is perpendicular to the radius at the point of tangency. So that means this makes a 90-degree angle. And this is considered a tangent line. So again, if I were to draw one right here, let's say if it was perfectly on the line, okay, this is a line of tangents, it makes that 90-degree angle. So that means this is my line of tangent, and this is perpendicular to my radius. All right, looking at this next one, something else you have to know. Tangent segments from a common external point are congruent. So looking at it, here are my two lines, my two tangent segments from a common external point. Here's my external point, makes these two segments congruent. Okay, so think of this as any type of cone shape, whether it's an ice cream cone or a snow cone, the two lines are going to be congruent. So even if I make a super small one, these are also congruent. So please be aware that those two lines are going to be congruent. All right, solving for examples. Please pay attention to these examples because you guys have to be able to identify specific things. So looking at it, looking at A, if OR is 6 and OT is 8, then find RT. Before I go ahead and label those things, looking at it, I have a tangent line. Okay, I have a tangent line. So if OT is tangent to circle R, then I know my radius and my tangent line make a 90-degree angle. So right here, I know that this is a perpendicular line. So I'm labeling it as perpendicular. And then go ahead and labeling what they gave me. OR is 6. OT is 8. How would I solve for RT? What am I going to use? What is it? What? I'm going to use my Pythagorean theorem. So I have a right triangle. They're giving me two sides. I have to solve for my hypotenuse. So what do I have? I have, not r squared. I'm going to have 6 squared plus 8 squared equals x squared. I'm solving for x. This one's pretty easy. It's giving me smaller numbers. So I have 36 plus 64 equals x squared. Adding these two together, I'm going to get 100 equals x squared. And then square rooting 100, x is going to equal, what's the square root of 100, guys? 10 is my answer. All right, looking at the next one, it says, if the measure of angle ORT is 45, right here, OT is 4, then find RT. So what kind of triangle do I have right here? Good, I have a 45, 45, 90 triangle. So what do I know about my 45, 45, 90 triangle? It's a special right triangle. So I'm going to go ahead and write that. I have a 45, 45, 90. Yes, I know it doesn't look like it's drawn as a 45, 45, 90, but that doesn't mean it has to be drawn to scale. What do I know? I know these two sides are congruent. It's isosceles. And then labeling, I have A radical 2. Do I have to solve for my A? No, I do not. They're already giving me A. So if A equals 4 and RT equals A radical 2, RT is going to equal 4 radical 2 as my answer. Questions on these two? All right, looking at this example, it says name a line tangent to circle P, but not circle O. So looking at it, just identifying because this is a little misleading. E is right here. D is right here. P is right here, B is right here, A is right here, and C is both of these lines right here. Okay, name a line tangent to circle P but not circle O. Which one's tangent to circle P but not circle O? Tangent to circle P but not to circle O. Which one is that? Huh? OB. You could either write it as OB or BO. Keep in mind they said it's a line. Looking at the next one. Name the common external tangent to circle O and circle P. Key thing here is says external. Does that mean it intersects or it does not intersect? Good, so it does not intersect. So I'm going to write that on there. It does not. And which line would that be? Which line would that be? What is it? CD. Okay, CD, looking at it, CD or DC does not intersect, okay? So if I'm looking at that line, it's right here. It does not intersect. Looking at the next one, name the common internal tangent. Internal. Does it internal intersect or does not intersect? Good. Internal does intersect. Good. This one would be AE. Okay. AE or ED, however you want to write it. Keep in mind, it is a line. Tangents are lines, so please don't forget those arrows. Looking at example number 4, it says circle M and circle N are tangent to P. PR and SR are tangent to circle N. And circle N has a diameter of 16. PQ equals 3 and RQ is 12. So looking here, they gave me my diameter. So I'm going to go ahead and I'm going to draw the information they're giving me. Here's my diameter. Make it a little thicker. This is my diameter. My diameter equaled 16, but I'm going to go ahead and what would my radius be if my diameter was 16? 8. So I have 8. I have 8. What else do I know? They gave me PQ. PQ was 3. And then they gave me QR, which is 12. Before I look at what they want me to find, what do I know looking at this diagram? Who could give me other measurements? What do I know? Looking at this diagram, what do I know? What can I find out? Sophia?
RS is 15.
Okay, RS is 15. Is anything else 15? Good, this is 15, PR, RP, whichever way you want to say it. This is also 15. What else do I know? Do I know the diameter of my other circle? I do, good. I do know the diameter of circle M. The diameter is 8. Do I know the radius then? No, the radius of circle M. What would the radius of circle M be?
4.
Good, 4 and 4. Is there anything else that I know? Anything else? Okay. Let's go ahead and find out if we answered all the questions already. PM. Do we know what PM is? Okay, we found that. It's 4. What about MQ? Do we know what MQ is? No, so we're going to have to solve for MQ. So looking at this one, solving for MQ, I'm going to go ahead and look at it. Looking at MQ, do I know specific information about MQ? Right here. I do know that I have a perpendicular line because I have a tangent and a radius that makes a 90-degree angle. So I'm going to go ahead and find MQ. How would I solve for MQ? Let's go ahead and see what we have. Here's my triangle. Let me make that a little smaller. Here's my triangle with my 90-degree angle. I have 4, I have 3, and I'm solving for my x. How would I solve for MQ? Pythagorean theorem. So I'm going to go ahead and write it as 4 squared plus 3 squared equals x squared. And I'm solving for x. I'm going to get 16 plus 9 equals x squared. Adding these two, 25 equals x squared. And what's the square root of 25? Good. So now I know my answer. MQ is 5. Do I know what PR is? Yeah, what's PR? 15. What about SR? 15 as well. And then what's NS? How do I know it's 8? NS is not my diameter. Good. NS is going to be 8 because it's my radius. And then do I know what NR is? No, I don't. I'm gonna have to solve for NR. So again, here's NR in my black line. I have my tangent and I have my radius, so I have a 90-degree angle, and we did say that this was 8 here, so I'm gonna go ahead and label it. So going ahead and solving for NR, I have my triangle. It's a right triangle. I have 8, I have 15, and I'm solving for my hypotenuse. Using the Pythagorean theorem, I'm going to have 8 squared plus 15 squared equals x squared. Solving for my x, I'm going to get 64 plus 225 equals x squared. Combining my like terms, meaning adding them together, 289 equals x squared, and then square rooting. What's the square root of 289? Good. X equals 17. Okay, so please make sure you guys are able to identify those right angles when you're solving. It'll make it a lot easier when you're finding information. All right, this one says, point B is a point of tangency. Find the radius R of circle C. So looking here, looking at my circle, do I have a right triangle? Yes, I do. So I have to solve using my Pythagorean theorem. So what do I have? Writing it, I need to solve using my a squared plus b squared equals c squared. I have my a, I have my b, and I have my c. Please pay attention to how I'm setting this up. My a I'm going to write as r squared plus 24 squared equals my c. Keep in mind you have to add everything. So r plus 16 squared. That's what it should look like. Now I have to solve for that r plus 16 squared. Keep in mind, just writing it for reference, r plus 16 squared. You cannot distribute it. Please do not do that. You're going to get the wrong answer. You have to FOIL it. So I'm going to have r plus 16 times r plus 16, and then solving it. Yes, there is a trick for this. However, you'd have to go back and look it up because I'm not going to go over that right now. I feel like we all know how to FOIL, so let's just go quickly through this. R times r is going to give me r squared plus r times 16 is 16r plus 16 times r is 16r. 16 times 16 is 16 squared. So combining what I have, I'm going to have r squared plus 32r plus 16 squared is going to be 256. So I'm going to go ahead and plug that into what I originally had. So I have r squared plus solving 24 squared is 576 equals plugging in what I have, r squared plus 32r plus 256. All I'm going to go ahead and do is I'm going to solve for r. Who can tell me what are we doing first? What do I move? What do I move over? What am I subtracting? What do I have to do? What can I do first? Yeah.
We subtract r squared from the right side and
Okay, go. Yep, I'm gonna do, you told me to do that one first. I'm gonna go ahead and do that one first. I'm subtracting my r squared from both sides, so I'm gonna have 576 equals 32r plus 256. Now what can I do? Good. Subtract 256 from both sides. So then I'm going to get 320 equals 32r. And again, I'm solving for r, so what do I have to do? Divide both sides of my equal sign by 32. And r is going to equal perfect. R equals 10. All right, questions on this example? All right, go ahead and try the next example on your own. I'm going to give you guys some time and then we're going to check it. Okay, going over this one, checking your work. So I'm using the same method because I have a right triangle. I have my A, I have my B, and I have my C. We could have just switched our A's and our B's. I'm still using Pythagorean theorem. A squared plus B squared equals C squared. So what do I have? I'm going to have 14 squared plus R squared equals 7 plus R squared. Whether you wrote it as R plus 7 or 7 plus R, it should be the same thing. Now I'm going to go ahead and solve for my 7 plus R squared. 7 plus R times 7 plus R. If you solved correctly, you should have had 49 plus 7R plus 7R plus R squared. 49 plus 14R equals R squared, or not equals R squared, plus R squared. And then I'm going to go ahead and plug it in right here. 14 squared, I'm going to get 196 plus R squared equals 49 plus 14R plus R squared. Now I'm solving for my R. I'm going to subtract my R squared first. They're both going to cancel out. I'm then going to have 196 equals 49 plus 14R. I'm subtracting 49 from both sides. I'm then going to get 147 equals 14R, and yes, it's fine if you got a decimal when you divide. If you divided correctly, R equals 10.5 as my answer. Questions on this one? Okay. All right, looking at the last slide, it says point M and N are points of tangency. Find the value of x. So they're points of tangency. What do I know about tangent lines? When they intersect at a common external, what do I know about these two lines? They're congruent lines. Perfect. So setting this up, I'm going to have x squared equals 9. How do I solve for x? What do I have to do? Good. Square root it. So x is going to equal 3. That's a pretty easy one.